Okay, in this video we're going to go through a sample problem dealing with some conversions going from different concepts of one substance to another. And what I mean by that, you take into account that super secret conversion factor that, remember, only you guys know in this world, right? Okay, and that is, if you guys remember, as we've been talking all along, 1 mole of a substance is equal to, that's an equal sign, 1 molar mass, okay, of a substance, which is equal to the Avogadro number of a substance, okay, which is also equal to 1 mole of a gas, or pardon me, which is also 1 molar volume of a gas at STP. Okay, and that has to happen. Okay, and remember how we derive these things. Okay, 1 molar mass, if we're talking about molar mass, okay, you have to use this tool. You have to use the periodic table to derive the molar mass. Remember, the Avogadro number is named after that dude, Avogadro, okay, and that is 6.022 times 10 to the 23rd particles. And remember, molar volume of a gas is 22.414 liters, all right, of a gas at STP. And if you don't have at STP, if it doesn't tell you at STP, you cannot use that molar volume of a gas, okay? So now that we have all of that stuff taken care of here, I'm going to erase a couple of things to give us some more room because we should know it, okay? So we're going to take into account then, what do we need to be able to solve this problem? Well, first thing we always do is we have to identify our givens and our unknown. Well, our given in this case is 26.3 moles of sodium chloride. Our unknown, okay, is the mass, okay, because it's asking you how many grams of sodium chloride. Okay, so I know that my basic equation, or pathway, BEQ, okay, we could say, or pathway, is going to go from my given, as we talk about this millions and millions of times, from my given to my unknown. All right, so when I talk about going from my given to my unknown, I'm going to go from moles to mass. Okay, so I'm going to use, in terms of the super secret conversion factor up here, I'm going to use this right here, the mole, and I'm going to use molar mass. Okay, so how do I set that dude up? Then I can go right directly to it. So what I would do then, I would take, and if I know I'm using molar mass, I know I've got to have the periodic table as a tool to be able to solve part of that. So what I would do then, I would start out with my given. I've got 26.3 moles of sodium chloride, okay, times I want to go to my mass measurement, so I know I'm going to have my grams on the top, so I'm going to have to use my periodic table to calculate that, and for every 1 mole of sodium chloride, so I can factor out my sodium chloride. When you look at sodium chloride here, okay, with the sodium we have to then calculate molar mass, so I've got 1 sodium times 22.99 grams, 22.99 grams of sodium. Okay, I also have 1 chloride times 35.45 grams, 35.45 grams. Okay, so I then, when I calculate my molar mass there, okay, I got 22.99, okay, 22.99 plus 35.45, okay, so I've got 58.44 grams. So that value here goes right here, 58.44 grams, okay. So I'll take then, in terms of the calculation itself, 26.3 times 58.44, that equals 1,536.972, 1,536.972. I've got to use sig figs, and remember, we always go to the problem. We don't use conversion factors. I've got 3 sig figs here. So in this particular case, I would have 1.54 times 10 to the 3rd grams of sodium chloride. It is that simple, folks, okay? All right. If you have any questions, let me know.
Made with Doodlecast Pro.